Hello and welcome to the video presentation of our 2D pattern recognition algorithm that has been designed for the EEE 212 lab, which can detect a specific character from a finite alphabet set using a finite number of coordinate points. Each lab group were assigned a specific character set consisting of 9 characters. These were the characters that were assigned to us. We also had to add 2 extra characters which highlighted the strength of our algorithm. We chose F for its close similarities with E and left open-mouthed second bracket because it is basically the flipped form of a right open-mouthed second bracket. To understand how our algorithm was developed, one must appreciate how each character in the English alphabet has certain geometric features which sets it apart from others. Let us take the example of E. It clearly has an open mouth and points lie on only one side of its mouth. A straight line parallel to this open mouth having the same length, a line starting from its midpoint, and 2 other parallel lines contained between the terminal points. F, although very similar in property to E, has only one such parallel line. Similarly, all the other characters that were assigned to us have unique geometrical features, and it is in fitting a certain character to this geometry that the basis of our algorithm lies. But the geometry we discussed so far holds true for ideal characters, like this E, for example. However, the project required us to identify characters which can be stretched, skewed, or distorted, like this E. For that, we had to allow certain allowances in our MATLAB code. Let us at first take a look at how our MATLAB code works. For each character, we developed a function which takes the x and y coordinates as arguments. Then it tries to fit the geometry of that character onto the coordinates. If it succeeds, it identifies the character and draws straight lines between appropriate coordinate points to reconstruct the character it has identified. It then returns a 1 which stops the code from executing further. If it fails, however, it returns a 0, meaning the coordinates pass into the next character function, and this continues until the character has been identified. The command window shows the identified character, the confidence level, and the time it takes for the code to execute. We have used some very basic formula of coordinate geometry and normal geometry in our codes. Some of these include distance of a point from a straight line, checking on which side of a straight line a point lies, equation of a circle, the cosine rule, etc. Let us now dive into a function to recognize the character that we have discussed at length so far, the letter E. In this while loop, we have obtained the open mouth of E. It has done so by obtaining a pair of points and checking whether all the other points lie on only one side of the straight line formed by this pair. If it fails to find such a pair, this will not be recognized as E. Next, it finds the parallel line by making certain allowances. That is, the line need not be exactly parallel and of same length per our project requirement. It then finds the parallel lines and the middle line of E. Since the lines can deviate from straight lines, we have allowed the code to consider points in a line even if it lies slightly outside, in this case of 0.05 units. The points are then sorted per our requirement using bubble sort and then plotted. Similar geometrical concepts have been used in all our other functions. For extra credit, we are asked to find the confidence level for each character. We have done so. To find the confidence level for a character, we have checked how pronounced some of the major features of that character are. For example, in E, we have calculated the product moment correlation coefficient of these 4 lines. A product moment correlation coefficient equal to 1 corresponds to higher level of confidence. Similarly, we have checked whether these 3 lines are perpendicular to the vertical. If they make an angle of 90 degrees to the vertical, obviously it corresponds to a higher level of confidence. In a similar vein, confidence level for other characters were also found. Let us now look at some of the downsides and strengths of our algorithm. If we look at the downside, the algorithm is lengthy and hence difficult for others to decipher. Also, the code has some susceptibility to error if the user inputs a coordinate which exceeds the allowed limit by our code. However, the strength of the code lies in splitting its operations to several functions, offering it great flexibility. If there is difficulty in identifying a character, then bringing changes to only one code suffices the problem. Another excellent feature of our code is that its execution time is very quick and hardly ever exceeds 1.5 seconds. Hopefully this video presentation has been able to provide you with an overview of our code and algorithm. For further queries or info, please do not hesitate to contact us at our email addresses.